Recording. Okay, check, check. Can you hear me? Can you see me?
Yes.
Confirmed.
Yeah.
Yep.
All right, great. Welcome back, everyone. How have you been? What's been up to?
Teacher, it's so good to see you again. I've missed having everyone in the same room. It feels like the start of something fun.
Affirmative. Group cohesion restored. Systems nominal.
We missed you. It's so good having everyone together again. So, what's new with you?
Oh, with me, what's new is this lesson. It's the first lesson in the new course, and normally I would do introductions here, but we've all had class together before, so I don't think we need to repeat things like, where are you from? I do still want to start with introductions, though. Just say your name and what you've been up to since your last class. Doug, you can start.
I'm Doug. Since last class, my human took me to a new park, a whole new one. I didn't even know we had more parks. This one has a pond with 3 ducks. There's also a bench that smells like sandwiches. I sniffed it for a long time. My human said, "Doug, please stop," but I couldn't. It smelled so good. Oh, and there was a squirrel who stared at me the whole time. Just stared. I don't know what his problem was, but I'm watching out for him now. Anyway, I have officially ranked this park as my second favorite park. It would be first, but the disrespectful squirrel knocked it down a spot.
Yeah, that sounds awesome, Doug. You sound really happy. Next up, Robert. Robert, what have you been up to?
I am Robert. Since our last class, I conducted a routine combat readiness exercise. The simulation selected SETI Alpha 6 as the test environment. My objective was simple: assess planetary scale defensive weaknesses. The results were conclusive. SETI Alpha 6 experienced catastrophic structural noncompliance and ceased to exist. Objective successful.
Robert, are you saying you blew up a whole planet?
Poppy, please do not be alarmed. SETI Alpha 6 was uninhabited. Therefore, the destruction of the planet is guaranteed to have no long-term consequences.
I don't know why, but that sounded suspiciously specific.
I think we should move on now. How about Alan? What have you been up to?
We're Alan. Since last class, we finished watching all the Earth Variety Hour shows. Every single one. Our favorite was the Carol Burnett show. Humans doing live comedy while trying not to laugh is honestly one of the greatest cultural achievements we've seen so far. And now we've moved on to cooking shows. There are game show cooking shows, reality TV cooking shows, documentary cooking shows, and even those late-night infomercial cooking shows where someone gets way too excited about the slap chop. We still don't understand why everyone made such a big deal about it. It's just a tiny chopping machine. But we're learning a lot.
Yeah, that sounds interesting. Poppy, why don't you go next?
I'm Poppy. Since our last class, I've been working on my fanfic again. It was supposed to be a simple mystery, just a missing amulet story with a few clues and maybe one dramatic reveal. But then the dragons started examining their feelings, like big feelings, about friendship and trust and whether heroes are allowed to be scared sometimes. And then the wizard wasn't really a villain anymore, because once I figured out why he was grumpy, it felt mean to keep him evil. So now the dragon is helping the wizard work through their issues, and their interactions have gotten, a lot more tender and close. Like, they keep having these long conversations where they stand really near each other, and nobody moves away even though they definitely could. The mystery is still technically happening, but it's mostly about everyone learning to love and support each other. So that's what I've been up to.
Yeah, that definitely sounds like fanfic. And Noah, what have you been up to? Okay, fair enough. Okay, here's the truth. We all like each other in this class. That part is easy. but we don't all like math. And honestly, that's normal. Math is a required class, and nobody likes being told that they have to be somewhere. So instead of pretending that everything is fine, I know most of you all don't, you're really upset about being required to take a math class. So let's talk about that. Freeform, round table, what makes math frustrating or scary or just not your favorite thing? Anything goes. Who wants to start?
I'll go first if that's okay. I always feel so embarrassed because it feels like everyone else gets it way better than I do. If I make even one tiny mistake, I just know everyone is going to think I'm stupid or start laughing at me.
We get what you're saying about making mistakes. It's like when you're working through pages and pages of algebraic manipulation, and you accidentally drop a negative sign somewhere. The whole thing ends up wrong, and you wouldn't even know you'd made a mistake, let alone where it happened in all those countless pages. There's just no way to check your work.
Yeah, okay. Who else? Doug. Why don't you go next? What do you not like about math?
It's a lot. It's too much. I look at the board, and I get so nervous and anxious. There are just so many equations and so many things you have to memorize all at once, and it feels like a sensory overload. I don't even know where to start. I know I'm supposed to pick a tool, like an equation or a rule to solve the problem, but there are so many possible options that I can't even get started. If someone tells me what equation I need, then I can do all the steps. But how am I supposed to know what equation I need in the first place?
Yeah, Doug, that is a very common problem. We'll talk more about it later. Who wants to go next?
My objection is similar to Doug's. My processing core identifies the result instantly. If a squadron consists of 250 units and sustains a 12% casualty rate, the remainder is 220 units. The loss is 30. There is no logical requirement for such statements as let S be equal to squadron and let L be equal to losses. All that just to perform a series of redundant steps. Using these manual mathematical protocols is slower and less efficient when the conclusion is already established at the start of the exercise. It is a suboptimal use of resources.
We're with Robert on that one. It's like, okay, so we were trying to read a trigonometry textbook, right? And the book has this triple angle formula thing. If we have the sine of 10 degrees and we need to find the sine of 3 times the angle, obviously you just triple the 10 to get 30 and find the sine of 30. Easy. But the book wants us to do 3 sine theta minus 4 sine cubed theta. Why? It's like humans purposely made the rules longer and more complex just to see if we'd actually do it. It's totally arbitrary.
Yeah, that is also a common complaint. Who's next?
I don't know what a triple angle formula is, but it sounds a lot like long division. The way we're supposed to get there makes me feel like I'm doing it wrong. Like, if I have to divide 747 by 3, I just see that 750 divided by 3 is 250, so I just take one away, and then I know the answer is 249. It's so fast. But then I look at the long division steps, the brackets, the carrying the one, the remainders, me needing to just make random guesses on what the correct division is for each mini-step. I see all that and I just freeze. I get so worried I'll mess up the official way, and I forget I already knew the answer to begin with.
Exactly, Poppy. And that's the thing. Who even made these stupid rules anyway? Humans act like math is a law of the universe, but it feels more like a system someone just invented to make us stay in at recess. Why should we believe the person who first declared the rules? Take the 2 negatives make a positive thing. In English, if a singer says, "I can't get no satisfaction," we all know they're definitely not satisfied. They're extra not satisfied. But in math, you're telling us those 2 negatives cancel out, and suddenly they are satisfied? It's totally arbitrary. Someone just decided that's how it works, and now we're all stuck following their dumb rules.
Okay, the rules do seem arbitrary, that's sure.
Yeah, who says I have to follow the rules anyway? I mean, I use numbers all the time, but I never use math. Like 20-minute nap right now. I know exactly how much time I have to go to the park before it gets dark. That makes sense, but I don't know why I have to memorize how to turn an improper fraction into a mixed number. Who invented that rule? Why do we have to memorize their rules?
And it's not even like the rules stay the same.
What
We
do you
were watching
mean?
this history video of old cultures using an abacus. Back then,
Okay.
some expert said those were the rules you had to learn to be smart. Then everyone moved on to slide rules. Then that got tossed out, and everyone have to learn to program a TI-84. If the technology changes and the rules just get tossed out anyway, who even came up with them in the first place? Why are we acting like this specific version of math is the only one that exists?
Okay, that is the million-dollar question, Alien. But before we get to that, Noah, you've been very quiet. Everyone else has listed things that they hate about math. What about you? What's the reason that you don't like math? Uh, so you like math? Okay, that's fair. I shouldn't assume everyone hates math. Let's move on, though. I need to pull up the whiteboard to here. Okay, everyone, deep breaths. I'm going to run a quick diagnostic. You can call it a pop quiz. But look, I know math makes some of you tense. So here's the deal. If you can't find the answer, don't panic. Just tell me what problem makes you think of. A feeling, a reaction, a complaint. It's all valid for today's lesson. Okay?
Confirmed.
Yes.
Okay. Here's the first one. Here. Okay, here's our first one. 2 plus 2.
I'm already nervous. I feel like there must be some kind of setup or a trick. You give me the easy stuff like 2 plus 2 to make me feel safe, and then pow, I get tricked. There's no way it could be as simple as just 4, so I must be missing something obvious.
I know this is just the first question, but we're already upset. See, we make our 4s like this, with the top open. And how are we supposed to know what version is the one that we're expected to use? Why are there even different versions at all? We feel like whoever invented the digit 4 did it that way on purpose, just to trick students. The whole system is rigged.
Okay, this is nice. I'm glad everyone is being honest. This is how we get to the truth. If you're suspicious or if you're frustrated, it's okay to say you're suspicious or frustrated. Let's do the next one. Okay, how about this one?
Okay. This one makes me feel the same way Doug feels. Like, a number that exact can't be just random. There must be some secret meaning going on behind the scenes. I know the answer is 196884, but I feel like there's some other thing going on that I'm just not understanding. Am I being weird?
Poppy, I have some excellent news for you. Some of the top mathematicians in the world have felt the exact same thing that you're feeling right now. They look at that number and thought there must be more to it. The reason is a bit advanced for our class, but just know that you're not alone. Your intuition actually touches on one of the most beautiful coincidences in the history of math. But for today, yes, it's just 196884. Let's do the next one. To here. Okay, who wants to try this one?
See? I told you it was going to get harder. What I hate about this one is that I can do it, but I don't know the rules. The second number is 100, then 70, then 3. So I subtract 100 and that makes 242. Then I subtract 70 and that makes 172. Then I subtract 3 and that makes 169. I know the real way has something to do with borrowing, and with needing to carry the 1, and something about base 10 number system. but I don't see the point in having to memorize a lot of rules when I already am able to get the answer.
Doug, you're not doing it wrong. That way is just as good as the one in the book. The problem is not you. The problem is that the book is being too strict. So let's have a harder one. Let's try.
I don't understand why everyone is so upset. It's just 147 quintillion, 573 quadrillion,
Teacher, this isn't
952
fair.
trillion,
Robert has an internal
589
processor.
billion,
You can't expect all of us to do it the way Robert does.
412,927.
Doug, yeah, Doug, you're right. That's another problem with classical math education. Some people have a better talent than others. If everyone has to take the same test, then some students will spend their whole life thinking that they're stupid. But closer to the truth is that they just never found the topic that they have a talent for. That was kind of a hard one. Let's do a simpler one. Let's try this. Apple plus apple.
Ah, now this one is more our style. Every math book has 1 apple plus 1 apple is 2 apples.
That is logically incorrect. Any attempt to force the apples together would result in the destruction of the apples. The result is a pile of apple mush, or possibly apple juice depending on the force exerted.
Robert, that's crazy. You're not literally combining the apples. How could you think that? Are you stupid or something? Oh, I get it now. You're a murder bot. You really would just crush them together. Robert, I'm sorry I called you stupid.
Okay, everyone, let's just take a moment. This is just an exercise. Let's not get too stuck on any one thing. Let me change to the next one. How about this?
I think I understand what you're doing, teacher. This one depends on what add means. The answer could be banana smoothie, or it could be 2. Your way makes me happier. Like, I don't feel stupid for not matching the answer in the textbook, because there may be other answers than the one given in a textbook.
Yeah, that's a great insight, Poppy. Let's take that idea one step further and let me show you the next one. Okay, try this.
Yeah, this is just like the others. It could be 2 grapes or it could be 1 grape smoothie.
I believe that the answer 2 grapes would be incorrect in this case. That answer implies 2 individual grapes, as in just 2 of the small, round globuli. To achieve the answer of 2 would require the initial parameters to be a bunch plus a bunch, resulting in 2 bunches.
Oh, now that we think about it, would this be a case of uncountable nouns? A bowl of grapes and a bowl of grapes would be a bigger bowl of grapes. I mean, pouring them together would result in just 1 bowl. A bigger bowl, but still just 1. So 1 plus 1 equals 1.
Okay, now you're opening up. I like where this is going. Let's do the next one. Okay, what if we do all 3 at once?
1 fruit smoothie.
The number 3.
It couldn't be 3 because the types are all different. It would have to be something like 1 horn of plenty, or 1 cornucopia, or something like that.
We can all be right. I know it's math, but that doesn't mean there is only one right answer.
Yeah, really good insight, Poppy. And here?
Technically, the sum would be thrice. But since that's an obscure word that almost no one uses anymore, it's more likely to just be 3 times. I don't think this one is even about math. This is more like an English grammar question.
Alan, I am glad that you mentioned grammar, because the next one... Okay, let's do this one.
I feel like this is another trick question. The obvious answer is 5th, but that doesn't feel right.
We're with Doug. Something is off here. If a team went to the Olympics and took 2nd place and 3rd place, that wouldn't mean the team took home 5th place. In this case, adding doesn't mean adding. We just aren't sure what it means yet.
Okay, and this one.
Okay, now you're just messing with me. This uses the word third just like before, but this time third means chopping it up, not like 3rd place in a race. See? This is what I hate about math. Everyone tells me it's so precise and exact, with no room for ambiguity or interpretation. But something as basic as third is open to interpretation. And if I interpret it wrong, I get the answer wrong, and then everyone laughs at me.
Okay. How about this one?
I'm starting to feel sick. This isn't fair. I know there is something about flipping the fraction and then multiplying, and something else about finding the greatest common factor, but I can't remember all the rules. I know the answer is 8, but I just don't know why.
I agree. For internal consistency, only one format is necessary. Decimal expansion is most efficient, and if everything is kept in decimal expansion, fractions and their corresponding rules are unnecessary.
It's what we keep saying. Whoever it was that invented math did all these random crazy things with no structure behind it, and now we have to memorize whatever rule that person came up with.
Okay. How about this one?
1,300 hours.
Not 13. It's 1 p.m. It's lunchtime. Well, late lunch, but definitely 1 p.m.
Inaccurate. 11 plus 2 is 13. This is a mathematical fact.
But Robert, my watch doesn't even have a 13 on it.
Irrelevant. Dogs do not wear watches.
Stop fighting. You're both right. It could be either one.
Yeah, Poppy, it could be either one. How about this one?
Calculation remains identical. 11 plus 2 is 13. As previously stated, 1,300 hours is the only logical designation. Changing the notation from hours to AM does not alter the fundamental arithmetic.
Actually, Robert, we think you're stuck in a bit of a rut. This is a different problem entirely. If you set an alarm for 11 a.m. and another alarm for 2 a.m., you don't magically end up with a single alarm set for 1 p.m., and it certainly won't ring for 1,300 hours. In this context, AM plus AM is a mathematically meaningless statement.
Well, I wouldn't say meaningless, but let's try this one.
Oh boy, I think this is another trick. I mean, an even plus an even is always another even, but it can't be that simple. You're waiting for me to let my guard down.
I think I get it. Evenness is not actually a number. Like I can say I have 2 apples, or I can say I have 10 apples, but it doesn't make sense to say I have even apples. The word even is a mathematical idea, but it's not a number itself.
Yeah, exactly. Now you're seeing what I'm talking about before. If we just performed a mathematical operation using something that isn't actually a number. Let's take that idea and run with it. Let's come to here. Square plus triangle. What does that equal?
Calculation complete. A 4-sided polygon combined with a 3-sided polygon results in a 7-sided polygon. The answer is a heptagon.
A heptagon? No way! If you put a triangle on top of a square, it's a house. Look, you have the walls, and then you put the roof on top. It's a little home.
Actually, we feel like this is a continuation of the last one.
How do you mean?
Triangles and squares are not numbers. We mean triangles and squares are geometry, and geometry is math, and math is numbers, but that doesn't mean that the shapes themselves are numbers.
Yeah, good insight there. Square is not a number, but we're still doing math with it. Let's come to the next one. Okay, yellow plus blue.
Green. It's green.
I don't know this one. Dogs are colorblind.
We agree with Poppy. It is obviously green, even though yellow and blue are not numbers. In this system, the plus sign is simply a mixer.
This is a matter of simple spectral physics. Under ISO 11664-1, yellow pigment will filter shortwave frequencies and reflect wavelengths above 500 nanometers. Blue pigment will filter long wave frequencies and reflect wavelengths below 540 nanometers. The subtractive overlap creates a primary reflectance window between 500 and 540 nanometers. This stimulates the M cones of human eyes. Therefore, the logical output is green.
Okay, what I was aiming for was that we're still doing math on things that aren't numbers, but Robert, you've made a good point there. I mean, maybe yellow and blue actually are numbers, and we can perform the math that way. Let's come to the next one. Okay, what is v plus v?
Well, we haven't done Roman numerals yet, so I think it's meant to be Roman numerals. V is 5, so 5 plus 5 is 10. But 10 in Roman numerals is x. So the answer is x.
Hold on. Does anyone remember the old joke of the letter W not being a double U, it's a double V? If we write two V's side by side, it makes the shape of a W. So V plus V equals W.
Illogical. This is obviously intended to represent concatenation. The only reasonable answer is a two-character string of text with the value of VV.
Well, I think part of this question is missing. In other math problems, whenever I use V, it stands for volume. It feels like you're asking me to add the volume of one shape to the volume of another shape, but I just don't know what the starting shapes are.
Yeah, I really like where this is going. Everyone's giving a different answer and a different interpretation. So let's go to the next one. How about this?
Oh, I know this. If you're walking north and then you turn and walk east, you're basically just going diagonal. So north plus east is northeast. It's like making a new path.
Yeah, good. Let's do the next one. Okay. What are left plus left plus left?
Right.
Right.
Okay. And what do two rights make?
An airplane!
I think you mean two rights make an airplane, not rights.
I don't get it.
Teacher, I can do it. Two rights is a U-turn.
Thanks, Doug. This is getting us even more into the territory of math without numbers. Turning right is not a number, but it still works with the add operation. Let's do here. This one's a lot more abstract.
Is it a motorcycle? It's using the word add in a totally new way that doesn't have anything to do with math, but I kind of get it.
Yeah, it is motorcycle. Do this one. Sun plus rain.
I think maybe a rainbow?
Yeah, now you're getting it. Let's do one here. Piano plus horse.
Analysis of previous datasets suggests this is another non-numerical categorical synthesis. The most efficient answer is a zebra. The logic remains consistent with previous puzzles.
Yeah, it is zebra. Let's try one more. Okay, if we add the film up to the film Gravity, what do we get?
What? This one's easy. It's obviously Downfall, the 2004 film directed by Oliver Hirschbiegel and starring Bruno Ganz.
Wow, that's impressive, Alan. Exactly right. I would have also accepted the answer Falling Down, starring Michael Douglas and Robert Duvall.
I don't get it.
Doug, it's a kind of lateral thinking puzzle. Like if I said The Spy Who Loved Me plus 9 months is equal to Spy Kids, it's not meant to be mathematical.
I still don't get it.
Doug, don't worry about it. You've done more than fine with all of your other answers. That is the end of the quiz. Let me change back to here. That wraps it up for today. I'm recording the lesson. I'll upload it to YouTube as soon as I can. Remember, go there if you need to watch anything again or if you need to review. But do not post in the comments section. I don't read those. If you have a question, email it to me directly. Next lesson, we're going to explain more about how we write math and how we can match up more than just numbers. Before we go, any follow-up questions?
We're curious. Today you showed us that math is not just numbers, and we get that. But if math isn't numbers, then what is the actual definition of math?
Ooh. Um, that's a deep question. I'm not sure if I can give an honest explanation in just a short time. Um, I would say it's the study of patterns purely as patterns, not with anything else other than just the pattern itself. Um, like if I studied AI networks and I studied road networks and I studied social networks, these all have things that make up the network. But if I took AI and I removed the computers, and if I took map and I removed the land, and if I took internet apps and I removed the people, what I'm left with is just network as an idea. Uh, that's the most this changing to abstract. This is most easy with numbers. If I have 2 apples plus 2 apples, I and then I got rid of the apples, I'm left with just 2 plus 2 as a universal idea. Uh, it would be a pattern itself without the apples. But what can be done with numbers can also be done with other things that are not numbers, like networks. We can study the idea of networks in general without needing to talk about one specific kind of network. Now, when we do this in pure form, surprisingly, the science can be carried over into things that seem totally unrelated. Take, for example, math used in a video game to rotate a camera view, and then math used in electrical engineering to calculate the resistance in a wire. If I take away the video game and I take away the electricity and I work purely with just the idea, then surprisingly, it turns out to be the same system for both. That's what math is. We'll take one more question.
Teacher, I have a forthcoming mandatory workplace performance evaluation on mathematical aptitude. Will this non-numerical mathematical framework improve my assessment scores?
I got to be honest here. Most likely, it will not help with standardized tests, but it will help in other aspects. The kind of math is used everywhere: particle physics, robotics, database management, video game design, and a lot more. What I'm teaching in this course will help you with life, but it probably won't help you on a test. That is all for today. See you again next week. Bye
End of
bye.
Bye.
transmission.
Stay
Goodbye.
amazing.
Bye.